Hey there, everybody. How you doing? Let's get that out of there. Welcome. Today we're going to talk about the second fundamental theorem of calculus. The first fundamental theorem of calculus I've learned people are pretty good at, but the second one a little bit more daunting. So we're going to go over the simple case, and then we're going to go over one of the cases that's a little more difficult. Um, the second fundamental theorem of calculus says the derivative of the integral of a function um, is the function. Not very exciting, is it? The tricky one would be the derivative of, a is just a number. Okay, let's start with that. So if it goes to a number of f of t dt, well, that's the same thing as writing as d dx times the integral of a to x of negative f of t dt. So when I do this one, it's just going to be negative f of x. Um, that's round one. Um, where it gets tricky is when I take the derivative from a number to, let's say, x squared. Let's give it a function. Ready? Square root of t minus 4 dt. Okay. Um, well, second fundamental theorem of calculus says to plug it in. So we're going to do that. So that's the first thing is you notice on these ones up here, you just plugged in x into the function. That's it. So we're going to plug in this into the function. So this is x squared minus 4. Done. But here's the catch. Whenever you take the derivative of something, you have to do the chain rule. Chain rule says that you need to multiply it by its derivative. And the derivative is 2x. That's it. The simple case would look like this of what if I had interval from a number, let's give it a number, let's say 5, to x of sine of t minus pi dt. Well, since it's just an x, just simply plug it in because the derivative, um, you're finding the derivative of the antiderivative. They undo each other. And so you would get sine of x minus pi, and that's it. Now, let's do a tricky one. Now, you could actually do all these. This is very important, you could just take the derivative, the integral, the antiderivative of this, and you can find out what it is. And then once you got it, could you take the derivative? That's it. This is providing us a shortcut. It's also allowing us to do things that sometimes we get stuck and we can't do it. So last example is this. Integral from 2 to 7 of x squared minus 4 dx. Well, let's think about this. If I were to take the integral from 2 to 7 of that, is it okay to say I would get a number, that I would be finding an area, and that area would have an actual number to it? Okay. So you get a number. Well, let's go here. What happens when you then take the derivative of a constant, of a number? What do you get? Wait for it. Did I hear you say it? Good job. You get 0. When you take the derivative of a constant, you get 0. Because the slope of a constant line, a flat line, is going to be 0. So to recap, to make sure we've got the basic idea down. So to recap, the derivative of the integral from negative 7 to x of square root of t minus t to the 7th dt. Well, it's hard to take the antiderivative of that, so I can't really do it. So I have to use the second fundamental theorem. And the fundamental theorem says, as I take the derivative of an antiderivative that goes to an upper bound of x, I just get, I just plug it in. That's it. Now, if you take the derivative of something to the x to the 5th of sine of t dt. Well, I plug it in, sine of x to the fifth, and then I also have to multiply it by the derivative of the upper bound. Okay. Last one, the derivative of anything that goes from a constant to a constant of any function, you get 0. There you go. Second fundamental theorem of calculus. It's something that I see a lot, and seems a lot of people struggle with it. Thanks for tuning in.